¿Qué pasó? You on mute.
Oh, I got excited, and for what? Because you didn't even hear me.
I seen the hand throw up though. Give me just a minute, niece. I got to do something real quick.
No problem.
Boy, these allergies, they getting on my nerves.
Ooh, excuse me. I mean, as soon as you say that, I don't even got allergies.
What's going
What's
on?
up, brother?
Greetings.
Hey,
How are you doing?
I'm great.
Any questions at all before we go live?
No, I was looking over the problems and I like them.
Okay.
I like them.
You said what?
Yeah. I said I like them. I was looking over the problems. I like them.
I was trying to keep it simple so we can capture more people. Hopefully, your people from your page will kind of join in as well. I'm going to record it so that we can put it out on YouTube as well, and then just kind of reshare it. And I'm hoping that we can kind of keep the conversation going. You'll notice that on the first page, I put that we're stimulating progress through community engagement. So I don't know what y'all are seeing every day, but what I'm seeing every day is the pits. It is the pits. I am in the trap. You hear me?
Mm-hmm.
And it's very frustrating. I am trying to keep myself as motivated and not overwhelmed as possible, but just seeing how many kids look like me who are struggling, and it does not seem like there's any light at the end of their tunnel. It does something to me, and it's weighing heavy on me. So I need it today so that I can get pumped up about some math. So yeah, let's do it. All right, I'm gonna go live. Give me 1 second.
This is not a drill.
Amen. Amen. Get in there.
Somebody just sent me somebody I know just sent me a picture of a math problem.
Uh-oh, they need some help.
Yeah.
I love your nose,
yeah,
man.
I like it. Yeah. Keeps me sharp.
Man, I get them things all the time. Lord have mercy. Glad they using their resources.
Mm-hmm. That's a big thing too. Like just having I realize it takes a certain level of confidence just to be able to ask for help.
True.
Even if you don't know how to do it, like, because the way a lot of people are oriented to math, it's like I don't even want to think about it. I don't even want to try to get the help if even if it's help available. That's that's one level that I used to take for granted, because like a lot of people say, like, it's resources here, it's all these resources, but it's like if you got that anxiety, that discomfort, even if the resource could be right there, you don't, you like froze.
Yep.
You don't even want to, look nothing up or try to figure something out.
Yeah.
And then you might not have the confidence to feel like if you look it up that you'll be able to figure it out. So a lot of people, like, they have a lot of this negative self-talk. It's real, like, self-deprecating. And that's the thing, like what we be saying with the kids, parents pass it on to their children.
Yep.
And then their children get it honest. And then their children be thinking, I'm not going to expect to be able to be good at math either, because my parents not good at math. So why would I think? You know what made me think of? It made me think of that scene from Five Heartbeats from the beginning, where Eddie Kane was talking to his pop, and he was like, "You ain't gonna be Ish, cause I ain't
Cause
Ish."
I ain't, yep.
It made me think of the same exact. It's the same exact dynamic.
It reminds me of a book that I'm reading. I know what to do, so why ain't I doing it or something like that? And he talks about belief systems and how a lot of times we end up believing things that are not necessarily rooted in like our own thoughts. They're influenced heavily by other people's
Yeah.
feelings and experiences, and then we just make them our own, and then we adopt them, and we start to believe that they are true for us too, and that's not the case.
Mm-hmm.
So
Absolutely not the case.
imagine that concept now in this era with social media and these Wi-Fi babies. You know, you think about it, we all grew up in an era where our parents and our tribe pretty much can control the external stimuli and the external forces on us. But now, I mean, there's a lot of parents out there that want to be vested in their children's education. But once that child get that cell phone and that social media, they don't even have to have social media. Once they get this bad boy here, we just open them up to the entire world.
That's so true. It's so true. All right. So I know we were getting ready to get deep into it, but I'm gonna pause us just for a moment just so we can get started. We are officially live now on Facebook. So feel free to share to your people, to your pages, let them know that we're here so we can have this good conversation with one another. I want us to start off by introducing ourselves so that we can let the people know, obviously, who it is that they are talking with and engaging with this evening. So whoever wants to jump in there, go ahead and jump in and let the people know who you are.
I'll start off. Dana Harris, math educator, roughly 19 plus years, online math tutor, and father, most important.
Yeah, I feel that. Yeah. I started Akil Parker, started teaching math in 2005, and by accident, almost sort of had a baby on the way, needed a job, and I just I never looked back. Taught a lot of places, taught on a college level, teaching on a college level at Cheney University, HBCU, and started a company called All This Math, where I'm trying to improve the relationship between the Black community and mathematics in general. And yeah, started the YouTube channel, you know, to help parents, help youth, help everybody. And I like math. Well, I used to didn't well, I love math actually. I didn't always love it though. I love it now because I understand her conceptually. I used to only memorize. I grew up memorizing the formulas and the procedures and the algorithms. I didn't really understand it that well, but now I understand it.
Good.
And
Okay.
and like Dana, I'm a father too. So yeah, that is the most important thing.
Absolutely.
Yeah.
Absolutely. So you guys are being super humble. Mr. Parker, like he said, he is a professor doing all these things on YouTube or on all these podcasts and doing all these interviews. Brother Dana Harris he already said he's been in it for a minute, but he got Young Gurus math tutoring. You traveling all around the world, supporting your brother, doing all kinds of amazing things. You've been tutoring for forever. You coached me whenever I first started teaching. So, y'all being a little humble today, but if that's how you roll, I'm gonna let you roll like that. But I'm gonna toot your horn. Okay. I'm gonna toot your horn. You guys inspire me on a daily basis. I love the fact that I am connected to people that look like me, but are of that male persuasion, who are out here doing amazing things in that math field. So we on my page, so y'all already know who I am. Lanisha here. I am a district math coach supporting a couple schools in Fayetteville. I also do a little bit of this and a little bit of that, but most of all, I just love math. I love being just immersed in mathematic talk because I see so often that people fear it. They are scared of it. And I feel like with just a little bit of understanding of the concepts, it just opens it up so much. And some of that fear just, it goes away, it dissipates. So I'm also a mother. I'm excited about that, mother and a wife, and among a host of other things. But tonight we're here to talk about some of the common pitfalls. We want to focus on a couple of things here. So we want to focus on the patterns and relationships. Now we're going to have a little conversation about homework versus no homework. I really want us to talk about that. And then we'll wrap up tonight. So I'm hoping that we'll get some engagement from the people on our page, because I have some activities for us to do that I feel like would just take it to the next level and allow us to really understand some things on a deeper level if we got some people to kind of get in here with us. But if not, it'll be just us, and we can share it out and we can get some comment on the back end. So without further ado, we're going to go ahead and jump into the icebreaker. Now, I know you guys have been to PD before, and people love icebreakers. They love icebreakers. So this icebreaker is actually one of my favorites because it shows you something and it asks you, what do you see and how do you see it? So y'all probably had an opportunity to cheat just a little bit. So I want you to put on your student hat, and I'm going to share the image, and I'm only going to share it for a little while though, only a few seconds. And I want you to think about what it is that you see and how did you see it? So again, put your student hat on. What did you see? How did you see it? Okay. All right, I'm gonna give you a moment to ponder on it. What did you see? How did you see it?
You want me to answer now?
I'm gonna give you a minute.
A minute? Okay.
A minute, just in case we got some thoughts we want to gather. This is usually how I would do it too. If I was doing a PD, I would give the folks a minute to think about it, and then we would come talk about it together. All right, let me hear it. What you got? What did you see? How did you see it?
I saw 6 faces of a die.
Okay.
Yeah, that's what I saw. The face with the 6 on it.
Okay.
I saw 6 groups of 9.
Okay. How did you see that, or how did you guys group them together? So Akil said he saw faces of a die. Dana, you said you saw 6 groups of 9. So what is it that you feel like was happening in your mind for you to put it together like that?
So for me, I saw the row of 3 dots, and then I was like, okay, well, there's 3 rows of 3 dots, so that's 9. And then I was like, oh, okay, there's 6 groups of that group of 9.
Okay. Akil?
I just saw the it like look. So yeah, I guess it is 9, but the way it jumped out at me, I just saw like it looked like 6. Because I just saw the black dots.
Mm-hmm.
I think the black dots jumped out at me. I didn't even actually count them.
Mm-hmm.
Yeah.
And that's fine, because there's no incorrect answer. There's no correct answer. It's just, what do you see and then how do you see it? So I've been places before where people would immediately kind of like group them together and then try to count them based off of how many groups they see or how many rows or columns or whatever. This is the first time that I've heard faces of a die. I'm gonna add that to my pocket. So the next time I do this, I'm gonna bring that up. So that was cool. All right, so let's try another one. So again, I'm gonna flash it up. I'm gonna give you a moment to see it, maybe like 7 seconds, and then I'm gonna take it away. So I'm giving you a moment to think about what you saw and how you saw it. All right, whenever y'all ready.
I saw a whole bunch of halves.
Okay.
A whole bunch of halves. I know it was 7 halves in one row, but that was the main thing I realized. A whole bunch of halves.
A whole bunch of halves. Okay.
Yeah, I saw the halves too. I assumed they were halves. I saw the legend or the key was like the circle equals 1.
Mm-hmm.
So then I tried to count the halves, and I was going to try to calculate the whole thing.
Mm-hmm.
And I figured it was 7 halves in one column, but then I didn't get a chance to count how many columns it was.
Okay.
So I actually was a little upset, not angry,
Me
but
too.
upset because I didn't have enough time to finish the problem. Because in my mind, I created a math problem. I thought I had to calculate the total amount of the black circles.
Okay. So let's talk about that. You said you got kind of upset. You didn't get mad, but you got kind of upset because you weren't
Yeah.
able to see it through. So today, while I was in class, they were doing a review because we're getting ready to go to EOG push. So we get ready to take these standardized tests here in about a week. And this little boy was trying to express himself. He was trying to share his answer, but what he was saying, I don't know if it didn't make sense to the teacher. I don't know if it wasn't what she was looking for, but she ended up calling on somebody else, and he felt like they said the exact same thing as him. He got so upset he put his head on the desk. Like he was completely checked out. And she said, "Nope, pick your head up, pick your head up." And he was so upset because he was like, "I said that. I said that." So the reason why I'm bringing this up is because you talked about being upset. So now, like, all of us are in classrooms, varying levels. Like, how do we help students who get frustrated as they are navigating through the mathematics?
I think for me, like, well, in this situation, it was an issue of like a lack of time.
Mm-hmm.
I just didn't have enough. I didn't have as much time as I needed
Mm-hmm.
to get to the problem. So I mean, I guess maybe with that, I mean, it's just an issue of like, if I had had more practice with this type of problem, then I would have been able to do it quicker, do what I was trying to do quicker then. But I think sometimes like there's more frustration when the students like it doesn't really matter how much time is allotted to them because they don't know how to do it anyway.
Mm-hmm.
A lot of times that's where more the frustration comes. And but I think it's because they haven't had enough practice and they're not willing to. They don't know that like like productive struggle is a real thing.
Mm-hmm.
Struggling through it and fighting through it, and like being a little, getting a little angry is like it's like part of it's like with sports, like you get a little angry, but that like motivates you,
Right.
like work harder.
Yeah. Okay. Dana, what you got?
I think when kids get frustrated about problems, I think there's different types of frustration. It comes to mind that kid that's gonna raise their hand, and you might be helping someone else, but they gonna get your attention, right? Like, Mr. Harris, you gonna answer my question, and it's like, wait, hold on, homie. Let me finish helping them first. But when it comes to time, I do agree with Akil on the fact that some kids, like, there's two sides to the timepiece, because some kids, if you give them a lot of time, they'll still waste the time because they don't know which direction to go with their thinking. So now we have the new math, which is supposed to create multiple entry points.
Mm-hmm.
Of the different entry points. So they don't even know when and where to jump into the problem. So I think that when kids get frustrated because or they finish the problem, that's a good thing. But the kids that get frustrated and just give up on them, just like Akil said, they don't understand the process and the fact that productive struggle is real.
Yeah. I 100% agree about I agree about the timing. Now, one of the reasons why this particular activity calls for a small amount of time for them to see it is to create that sense of urgency, right? So to keep the kids engaged, because we dealing with, for this particular example, we're dealing with middle school students. So we already know, hold on, y'all, because I got to figure out how to turn off these notifications. Woo. All right, so we're dealing with middle school students whose attention spans are really, really short. So we're trying to engage them, but we don't want to intimidate them at the same time, right? So finding that happy medium between what is too little time and what is too much time is always going to be key. Now, one thing I do want to highlight, though, I'm gonna scroll back to the very first one that I asked a question about. There is a skill that students need to have in order to be successful with coming up with anything to add to the conversation about this? And it's subitizing. Now, a lot of students don't have that skill. And I know that to be the case because I was working with some students today who it was a very small group of items that were kind of grouped together. And you would think, okay, these are arranged in an array. They can automatically see what this is. They wouldn't have to count one by one. But these 8th graders had to count one by one. These 6th graders had to count one by one. So I'm interested to know what your thoughts are on subitizing. Why is that so difficult? Why do we have students who are in middle school still having challenges with skills that were initially introduced in early elementary? Why do you think that's the case?
There may not be as much reinforcement or consistent reinforcement throughout the years. So it may be a skill that, and it may not have been fully understood at the early age when it was first introduced, or even if it was, if that consistency wasn't there, then it's like, if you don't use it, you lose it. So it could be some of that going on.
Absolutely.
Which is my audio better now, Niche?
Yes.
Okay. The practice and repetition. I don't know that children and a lot of parents understand how well. I think back before our internet days and things like that, where we did the same things over and over again. And so that repetition caused it to basically dig into our brain. And so with Subotai, mentioned he saw, right? He said dice. I started thinking about dominoes. I'm thinking double six, even though this is a double nine on a domino. So naturally, certain things that we all went through, is right because were shown to us repetitive, and it's tougher for them to subitize if they don't have certain specific visuals that are shown to them repetitively over time.
Yeah, so 100% agree with that. I think practice is a big piece of it as well. I was talking with a teacher a few weeks ago, and she said she feels like that the students overall across grade levels are getting less and less practice. So we have these skills that we are presenting or we're working on with the students, but then it doesn't seem like we're giving them enough time to work with it. All right. And so it seems like you guys are feeling the exact same way about that practice is not happening as much. So I want us to get into the homework debate in a little bit, but not just yet. I do want us to talk about that because that homework is where some of that practice is going to happen, especially outside the classroom, because the reality is in some classes you got as little as 45 minutes, you might have 90 minutes, but depending upon where you fall along that like that performance level, what your grade level is, there might not be enough time for us to get it all in the classroom. So that's why I added in that homework piece so that we can talk about how important it is for the kids to practice. So again, like I said earlier, we are coming together today to kind of talk about patterns and to talk about relationships between numbers. Okay, so I put this one up here because I wanted to post it out. I wanted to pose it out to see which of these expressions would somebody prefer to evaluate? Which expression would you prefer to evaluate? So I'll give y'all a minute to kind of look through them, and then y'all can kind of weigh in and let me know what you think. All right, whenever y'all ready, let me know. Which one resonates with your spirit?
I'm gonna say 10 times 1/5 because the steps that it takes to simplify that, I feel like I can do in my head much quicker,
Okay.
right? So I can either say 10 times 1 and divide that by 5 to get 2, or I could say 10 divided by 5, which gives me 2, and then multiply that by 1. So
Okay.
so for me, that's the simplest one to work out in my head.
Okay. So let's stay there for a minute. So you just gave us two strategies. You said that you could multiply straight across and do 10 times 1 and then divide by 5, or you could simplify with the 10 and the 5 and then multiply the 1, right? Okay,
Uh-huh.
so I want us to stay there for a minute. What are some other ways that students can, or what are some ways that students can conceptualize this? Like if they needed some type of visual, or if they needed help understanding or knowing what steps to take, how could we support them with that?
Um, we could take we could take the 10 and break it down into fifths. So I can take one whole and break it down into 5 sections, right?
Mm-hmm.
And have I have like 10 rods, right? But each rod, instead of it being a 10 rod, let's say it's a 5 rod. And out of that 5 rod, one of those 1/5 pieces, or I'm sorry, one of those 5 pieces are a different color. Okay.
Okay.
So if I have 10 of those, then now I end up with 10 1/5 pieces. And if I count up all the 1/5 pieces, it's going to give me 10 of those. Well, 5 of those is one whole, and the other 5 is another whole. So one whole and one whole gives me 2.
Yes. I'm glad that you brought up the fact that we have 10 1/5s, because one thing that I'm recognizing is like students' lack of understanding of unit fractions.
Mhm.
And so we go straight to, okay, let me go straight to trying to figure out, how do I solve this, memorizing the procedure or memorizing like the steps, but they're not understanding like, how does this really connect? How does this really connect? So Akil, which one do you prefer?
So I like all of them, but I'm looking at it in terms of like, I want the hardest one
Okay, which one
because
you think is the
I
hardest?
feel um I'm saying between the subtraction with the mixed number or the
Okay.
division with the mixed number.
Okay.
Because that's like that's good for my ego. I mean,
Okay.
I'm glad I know how to
Ah.
do all these, and I get to like it's like a flex, But then I'm trying to like challenge myself to like explain it in different ways.
Mm-hmm.
One of the things I was thinking about when y'all were talking about 10 times 1/5 is, well, one thing is this, a couple things. One thing that comes to mind is it's very important for students to call it a fifth as opposed to saying 1/5, because
Yes.
hearing themselves say that, if you just say 1/5, it's almost like the 1 and the 5 don't have no real relationship with each other, right? But if you
That
say
part.
it's a fifth, then that's a thing. Like that's something I can visualize. I can like hold on. It's like give me a fifth of that, right? And it's like then we get into like, okay, if it's 2/5, it's like, okay, how many fifths? So then when we start adding them, I got 3/5 over here and I got 2/5 over here. And now all together, how many fifths do I have? Because like when I explain common denominators, I always talk about money, right? And this is how I try to get people to understand like why the denominator has to be common and it's got to be the same. Because like if I got $2 and I got $5, you do 2 plus 5, but it's not $7. You just say the word dollars one time. It's just dollars. So the denominator is just that. It's like your currency, but you're not actually adding the word dollars to the word dollars.
Mm-hmm.
That's one thing. But I was thinking about like doing like a new monetary equivalent of 1/5, breaking that down, thinking of it as like 20 cent.
Mm-hmm.
So if I got 20 cent 10 times, and even that's like commutative property in like real time. I want to say this too. For so many years, I taught like when I taught algebra 1 and we went over those properties at the beginning of the year, like I really didn't know how they really manifested themselves. I just knew it was like, okay, yeah, when you multiply or add, you can switch the order around. But I didn't know that like, oh, in the elementary level or like, in pre-algebra and then the arithmetic, it can make the math easier. Just like even like on I don't know, like kindergarten, first grade, if you ask a child to do 1 + 9 and they're still counting with their fingers, it's a lot of opportunities for them to mess up because they got to put 9 fingers up and get all the way up to 10. But then you can tell them, like, you can flip it around and do 9 + 1. It significantly reduces your margin of error with a possibility for that. So then I'm like, oh, that's in real life, that's what the commutative property helps us to do. So even if I say, like, what's like 20 cents times 10, that's like commutative property and like in real life. So if you think about 20 cents 10 times, it's easier with quarters because it's like I got 10 quarters. How much money is that? But if I got 20 cents 10 times, then hopefully you can see it as $2. So then $2 and you convert it back to just an integer, and making sure they know what an integer is, because the vocabulary is very important. And that's another self-directed criticism I have, because for so long, I would take, like a lot of math teachers, I would take for granted that, you know what an integer is, or if I did explain it, I didn't really give a thorough explanation. It's just like, oh, it's just an integer. But all that, like that vocabulary is like very key, because you'll be bombarded on a standardized test with all these math vocabulary terms in one question. And it's almost like you're getting hit over the head with all these. And if you don't have a deep understanding of all the vocabulary, you'll just check out and you won't even want to do the problem. So I realized too, like, that with math vocabulary, we got to really, and I had to really like start like making sure like treating vocabulary like the way English teachers treat vocabulary, or foreign language teachers treat vocabulary, or science teachers treat vocabulary. Like the vocabulary is just like that important. Like even to the point, like I think if I was back in a traditional classroom, I probably give vocabulary quizzes, like just on the words, where they could just memorize what's an integer, what's a rational number, what is I don't know, what's a decimal, what's a factor and a multiple. Those are two big ones, because a lot of students confuse those or conflate those, factor and a multiple.
Right. So it's a couple things I want to hit on. So you said something about 1/5 and how critical it is for the students to say 1/5. So calling it its actual name. And I think students not doing that is why students are surprised when you tell them that there's a relationship between that division there. Because they're saying 1/. What in the world? What does over mean? Like, what operation is that? Like, what's the relationship there? So that's one thing. The other thing was, you said 20 cents 10 times. So another thing that kind of pops out to me about that is place value. A lot of students, like, if I understand place value and I know 20 cents 10 times, then boom, I can say, oh, that's $2. You know what I mean? But if I don't understand place value, if I don't understand those powers of 10, then I'm going to struggle with that. That's not even going to be a strategy that comes up to me, because I have no clue about the place value. And I'm seeing that regularly. The last thing that you mentioned that I want to hit is vocabulary. I was in a class today and you mentioned taking for granted that students understand the words that you're using. But I also want y'all to consider that sometimes teachers are using vocabulary incorrectly. And so now there's an inconsistency across grade levels, because I had one teacher that said this, and I had another teacher that said this, and they're talking about the same thing, but they're saying two different things. And then the other piece of that is not feeling like the vocabulary is too much for students. So the example I'll give is inequality symbols. If I hear one more time something about the alligator eating a number, I'm going to scream. Students have the ability to learn symbols. Why are we making it about an alligator eating a number? What is that even talking about? I don't know.
At least I can see they can say emojis now or something, because these, I'm the alligator been died back in my book.
Yeah, I mean, I can see it for the first introduction, like we first introduce it, but then beyond that, it's like, okay, we gotta do something more sophisticated now.
I really do. I really want us to hold our kids to a little higher standard. And I think I sent both of y'all. I was watching, Beyonce is my girl. If you don't know that, you know now. Beyonce, my girl. I was watching a Hulu document. Well, it wasn't really a documentary, but kind of sort of about her being in country music. And they're gonna put some statistics on the screen using the wrong inequality symbol.
Right. I remember that. You sent me that. Yeah.
Because they trying to remember what the alligator did. But if they knew symbols, we wouldn't have that problem.
The folks wanted the alligator to get her because she jumped into country music.
Oh my gosh, that tore me up so bad. But thank you guys so much. So what I want us to do now is I want us to look at each of these problems and kind of think about how students would enter them. Because eventually there are going to be some people that are going to engage in this content. There's going to be some people, I've already got a couple comments anyway, but there's going to be some people that are going to watch this. So as they're helping their kids, both of you guys have YouTube channels. So as they're helping their kids, we want to give them some different entry points or some things to look for. So neither one of you guys chose this one. So what entry point or how could students work with this particular problem?
You got to know vocabulary first.
Okay.
Because to Akil's point, you have to know vocabulary, and you have to know that in order to add two fractions, they have to have the same number of total parts, right? Okay. Which is that common denominator. Mm-hmm. So we got to take the same number of parts, and then now after you know that, okay, well, how do you find this common denominator? Now I got to know the difference between factors and multiples. Mm-hmm. You see what I'm saying? So now I have to know I can make a number larger and it have the same value, but it's much more difficult for me to make it smaller and it have the same value, if that makes sense. Mm-hmm. Right? So since I have that 5 as a larger denominator, we think about the multiples of 5, 5, 10, 15, 20, et cetera, et cetera. And let's hit the 25. And so then now we look at the multiples of 2. Well, 2, 4, 6. And all we're doing is saying 2 times 1 is 2. I love the way you drew that table. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. Another simpler way to think about it is counting by 2, counting by 5. These are 3 different concepts all in one. So then now we have to look at, well, what is the smallest number that row of multiples of 2s has in common with the row of multiples of 5? Mm-hmm. So in this case, we're going to go with 10 as you highlighted. But I can't just say, I got to know, how did I get to 10 from 2? Like, what did I multiply 2 by to get to 10? What did I multiply 5 by to get to 10? And then once I realized that, in this case, 2 times 5 equals 10. 5 times 2 equals 10. And now we got to be an equal opportunist. So whatever I did to that denominator to get to 10, I have to multiply the numerator by the same value to get to 10.
Mm-hmm. Thank you for spelling that out. Absolutely. So the reason why I did this table is because for my students who were struggling with knowing the difference between those factors and multiples, the thing that works the best for kids who are struggling is organization. That's from my experience. So having a way to organize it so they can see clearly what it is that I'm looking at and be able to dissect it, that has worked. So this table has been a game changer for several of my students and even some of my teachers as well. It has been a game changer. Akil, did you want to add anything here?
Yeah, so and this reminds me that like something that we already know, and it's not to discourage anybody, but it should really motivate us that we really are like educationally in like very dire straits, and there should be a real sense of urgency. And I say that because there are students that don't really know math, and at the same time, I think there are a lot of students that purport to know math or seem like they know math because they get strong grades, but they still don't know math. And I say that because I think I was one of those students. Because like I mentioned earlier, I was real big into the algorithms, the steps. Like if you showed me this problem when I was in middle school or elementary school, I would straight just be like, okay, I know I need the LCD. Boom, figure that out. That's going to be 10. And then I'll do the problem. But I never took the time to even think about, well, what does 1/5 really mean? Mm-hmm. Like if I had to show somebody what that is, I probably couldn't do it. Well, what does 5/2 really mean? right? I know I could convert it to a mixed number, but in terms of a fraction, like, and what makes it improper? That's another thing. So like really understanding like what a fraction really is. So 1/5, okay, you got an object. The denominator is 5, so it's cut up into 5 equal parts. My numerator tells me how many of those parts I'm focused on. So that's why it's 1/5. It's almost like that's the definition of it. The definition of 1/5. Like, what is 1/5? I couldn't do that when I was younger, right? I could get to the answer though. But then I would get jammed up on the standardized test because the standardized test wants me to really be able to define what does 1/5 mean, what does 5/2 mean, or like what makes it improper. Because with 5/2, if you got an object that's cut up into 2 equal parts, and then I'm focused on 5 of them, you got to step back and say, wait, hold up. How can I be focused on 5 if it's only 2 there altogether? So that's what makes it's like a glitch in the matrix. That's what makes it improper. But then that also explains why that means you're going to have multiple whole objects, right? So until you can get 5. So that's why, okay, if I got two pieces in one object, I'm trying to get the 5. So I shade those 2 in. I still need 3 more. So where I'm going to get them from? I got to do a whole nother object, cut that in 2, shade 2 more. I still don't got enough. I need another one. So I got to do another object, shade one of them in, and now I got my 5. And then when you see it visually, and that was another problem too, like I'm not big on like art. I don't like to draw stuff because I'm a perfectionist. And if my drawing is not going to be perfect, I don't want to do it at all. So I just like tend to like stick to the numbers, which I used to be like that because that's a problem because you need to be able to visualize, I think, and it even helped me as well. But just like being able to understand, like what does 5/2 really mean? What does 1/5 really mean before you even like get into that? I do have a question. Well, let me also say this. I think another thing, I know people hate the word memorize in education spaces, right? They don't like memorizing multiplication facts. They don't like memorizing nothing. But when I started thinking about adding and subtracting fractions with unlike denominators, I realized that really essentially what you're doing is you're trying to find an equivalent fraction that has the denominator that you're looking for. So I think if we have children to get into the habit, just as we have them in the habit of, or I think we should, and I still stand on that, regardless of what people on Instagram think.
I'm with you. I'm with you. I stand with you, brother.
That they should be memorizing multiplication tables, right? While still understanding the concept behind it, of course. They should be memorizing equivalent fractions, just like they should be memorizing what decimals are, what the decimal equivalents are to fractions, and vice versa. So then it's like it becomes a different situation because it's like if I got all these fractions in my head that I know are equal to each other, and then also it blew my mind when somebody pointed out to me that on the multiplication table, it shows you the row that it's also a row of equivalent fractions as well. You know, when somebody showed me that, because if you look at the multiplication table, look at like 2 rows at a time, like even with these right here, like 2/5 is equivalent to 4/10, 6/15, 8/20, 10/25. Like the multiplication table is the same way. So that's another way to like kind of if the student does have an issue with like memorizing the steps of, you know, finding the LCD, how do I find the LCD? You know, what do I multiply by what? You know, then they might think, well, I know 1/5 is going to be the same thing as 2/10, and 5/2, you know, might be the same thing as 25/10. So I know I need that 10, you know. The question I had is, how do y'all feel about finding just a common denominator versus the least common denominator?
The reason why I do least common denominator so they don't have to simplify.
Right.
Again. Yeah.
The numbers would be smaller. Yeah. Yeah. I've always been, that's how I was taught, least common denominator. But then I've seen people, they just, because people get into the whole, I mean, it doesn't really apply here, but like, you know, if your denominators are like 4 and 8, and instead of saying, all right, well, let's use 8, their whole strategy is just multiply the denominators together, regardless of what they are. Just multiply them together and see what we get. And it's like, yeah, we could do that, you know. So I had to get into the habit of, like, if I had a student that did that, I'm like, well, you're not wrong,
right?
But that's not the least common denominator. You're making your numbers bigger, which might create more work on the back end. right? But I just wonder.
So, all right. So there's a couple things that I want us to do. We got about 15 minutes before we wrap. There's a couple things that I want to do before we do that. One, I want us to look at this one because I want to share with you something that a student did. Okay. So this student, the interesting thing is this student has a habit of not really doing a lot of work in class, right? But during EOG push, he's in my small group. So they put him in my small group and we were talking about fractions or whatever. And I was like, just tell me, how would you do this? And this is what he did. He said, well, I would take the 3/4 and I would break it down into 1/2 and 1/4. So he got 2 and he has 1/2 and then plus 1/4. So this is what he recognized in his mind. And we're still subtracting 1/2, right? So when he did that, the class was like, what? Huh? They had no clue what was going on. But because he understood the fractions, he was able to decompose 3/4 in this way, right? So now this next part he didn't do. But once he did that, I took it to the next level. So then I got boom, boom, boom. When I tell you, I'm about to be I'm about to be 40. I never decomposed a mixed number in this way. When he said that, I said, boy, you better stand up and give me some. Like, I was so excited because he never does anything in his regular teacher's class. Never does anything. But I'm assuming maybe it's because he's bored because the way his mind is working is so much different than what the teacher might be teaching or whatever. But this is what he said. And I was like, oh, thank you. So just giving space for our kids to share their ideas, because the way we do it might not be the way that they do it or the way that they see it. You know what I mean? So
that's a great example of the new mathing. Like that's what I like about that because like I looked at that. You break it down, but that I would have definitely been extremely proud of that kid
because he understood.
Right.
He understood those unit fractions. He knew that was 3/4 or 3/4.
Right.
If I break them apart, I put 2 of them together, that's still a half, and I still have that 4th left. He saw that in his mind. He didn't write anything down. He just saw it. And so I was like, okay, you get the award for the day. Okay. So that's one thing I wanted to highlight and share. Okay. Another thing that I wanted to talk about. Well, actually, I do want to talk about this one because Akil brought it up. I do want to talk about this one because Akil brought it up. So why did you choose this one again? You said because it was a challenge?
Yeah, it seemed like it might be challenging, like one of the more challenging ones for me. Like the other mixed numeral one. You know, because it seemed like you got to do a lot. At first glance, yeah, you got to do a couple of things.
Okay. Well, I'm gonna pose a question then, and you tell me if it seems like now that it's gonna seem like you're doing a lot. All right. So how many thirds are in one whole?
I mean, if you do it like that, then it's kind of quick. Yeah, it's kind of quick if you
like
take that route. Yeah.
But see, the kids are gonna think about it initially the same way you did. Like, hold on now, we got a mixed number, we got a fraction. It seems like a lot. But if I'm asking myself how many 1/3 are in 9, and then how many 1/3 are in 1/3, boom, I'm done. 28 out of here. You know what I mean? So just thinking, that's again an example of the new mathing, as Dana said. The new math is mathing because it's a heavy emphasis on the concepts, those visual representations that's going to carry over when we start to move to that more abstract math. So we're probably not gonna have a lot. We're not gonna have a lot of time to go through all of our slides for tonight, but we can continue it because you guys said that you were down to make it a series. So that's what we're gonna do. We're gonna bring it back. So I'm just gonna show y'all this picture. So the question is, calculate the percent shaded. Calculate the percent shaded. So where would a student start here?
Count up all the pieces.
Okay, so find a whole and then.
So I see my visual shows me 3/4 automatically. even
Okay.
though it's eighths.
Okay.
And now that I know 3/4 is 75%, that's just memory though.
Right.
Like, and it's kind of
Right.
turned a little bit, so it's not your normal 3/4 to where the top right or the top left or the bottom left or the bottom right is shaded, not shaded. But I just kind of turned it in. Yeah, that's exactly what I did in my head. And I'm like, wait, okay, so a fourth is 2 of those slices. Oh, okay, well, 1/4 is not shaded. So that means it has to be 3/4 that is shaded. And then naturally, I know by memory that 3/4 is 75%.
I
Yeah.
am, Akil talked about earlier about the memorization. I support memorization. I feel like there are benchmark numbers that we should know and recognize. The ones that are going to be those high frequency numbers that we're going to see often. I feel like we should know them.
Absolutely.
Akil, what were you going to add?
Yeah, I mean, similar to the way Dana looked at it, just create the fraction and then convert the fraction into a percentage. But from knowing the equivalencies between fractions and decimals, from the fraction to the decimal to the percentage. Sometimes you skip over the decimal because if you know it's 0.75, then it's 75%.
And I took off the spatial reasoning part that I wanted us to talk about tonight, but this really hits it because you're looking at this figure and you're trying to decompose it to make sense of it. So that is a part of that spatial reasoning as well. So we really kind of hitting that too. But I'm adding this on right behind the fractions because if students have an understanding of equivalent fractions and they know that their whole is 100, then they can just scale up.
And I think too, and this is why I put I have a chapter in my book, and how to use all this math volume 1. I have a chapter on pizza. I call it pizza fractions, because these are like the opportunities that even parents that don't feel like they're strong at math, it's like, listen, every time you order a pizza, you get a pizza delivered to the house, or you pick up a pizza, y'all eat pizza for dinner. Like, this is like just something light that you can do, just a conversation you can have to reinforce this idea. About how much, like, okay, you had 2 slices of pizza, it's a large pizza, it's 8 slices altogether. What fraction of the pizza did you just eat? What fraction of the pizza is left? What percentage of the pizza did you just eat? What percentage of the pizza is left? Just them little things, like, but compounded over time, that helps the child to, like, when they go into the classroom, they're much more confident and they got a little bit more of a solid foundation. And it's like, and it's like a small thing. It doesn't require like a parent to go start taking classes at community college, math classes, or, really restructuring their life too much. It's just like, we could meet you where you are. Just like the stuff you're already doing is so rich with math opportunities. We just got to show people, like, look, like, you can use this. You know what I'm saying? Like, like, that's how I taught my son fractions. I taught my son fractions. Like, we used to watch football on Sundays when he was little. We would order, pizzas and wings and cheesesteaks or whatever. And that's how I introduced it to him. He took a slice of pizza. How much is that? He was like, 1. Like, yeah, it's 1, but what else is it? That's an eighth. 8 slices altogether. It's 8 slices altogether. That's your denominator. You took 1 slice. That's your numerator. That's the eighth. So it's like the way to introduce, because fractions is like, math is a language, but then within math, you got like different dialects. Like, you got the language of fractions within the language of math. And, even some people that are strong at math, it may not be as strong with fractions, people need to get strong with fractions, because it really is going to make a huge difference.
Absolutely. I think that that's why I wanted to have these conversations, especially on live, especially recorded, especially with all 3 of us here. Like, we need to have these conversations because, as simple as it seems, so let's talk about fractions with your pizza. It is simple for us because we talk this language every day.
Right.
There are a lot of adults who would probably be scared to have that type of conversation with their kids. So by us coming up here and talking about it and making it more accessible for the adult, then now that's going to empower them to have those conversations with those kids. So if y'all haven't checked out these YouTube channels, Young Guru Math Tutoring, all this math. If you haven't gotten the book, do these things, because the same way we want our kids to practice, the parents got to practice too, so they feel more comfortable engaging with the content. So we got 5 minutes. Real quick before we go, I know that I talked a little bit earlier about homework, and I pulled off a blurb online that talked about, I pulled it off from the North Carolina Council for Teachers of Mathematics. So they talked about early education, elementary school. It was kind of hard for them to see the correlation because students' attention spans were so short. But there was some impact, positive impact on students' performance on unit tests when it was skill-based practice and skill-based homework. Now, for middle school and upper grades, they said that there was a positive correlation between the amount of homework and student performance. And except for when it reached over 90 minutes. If it took over 90 minutes, then you can hang it up. They're not doing that. But it essentially said that those middle school and upper grade level students needed the homework, and that there was a positive result on their academic performance. Now, I don't know about what's happening where you guys are, but there ain't nobody giving out homework where we at. And a lot of people argue about homework because they say the kids aren't going to do it. And I understand people's situations are different. Some people have to work, even though they're really young. Some people are taking care of siblings. Life ain't set up for it, whatever. But what y'all thinking about this homework?
I'm a huge advocate of homework. That's a hill that I'm gonna die on. Like that homework hill. It's because it's practice. You know, you got to be able to practice and get the wrong answers yourself, and work through it, and remember how not to do it. And you got to. It's like with sports. You got to get your reps in. Like there's no substitute for that. And even like a couple of things, like when people say, well, we're not going to assign homework because the students aren't doing it. Like that's backwards. That's like, I mean, like, does that mean it has no value? Because like students may not be doing it. I think a large part of the time students may not do it because they may not have the study habits, or maybe they need help themselves, and maybe their parents don't understand it. So that just shows that we need to help the parents. The other thing about the research that people always cite, like, but they don't cite the research. That's the thing. They'll be on social media saying like, well, the research shows, and I'm like, yo, show me this research.
Right.
I want to read. So I did my own research. I found the research. I found some of these articles, and the articles did not come to that conclusion because it was kind of like, it was disaggregated for one, like how this is like with different grade levels, right, and also in different subjects. Like, I doubt there's no real research that says that like homework in math is not helpful.
Right.
I know the absence of homework in math is not helpful. I know that. I have my own data to support that.
Right.
But I'm just like, where's your research at? Because people like to just throw stuff out there like, oh, the research says, like, what research? Like, where's the article? I want to read the article that you read that shows conclusively that there's no benefit for when I teach how to solve systems of equations by the elimination method. Students don't need to practice that they don't need to practice that. And if they don't practice it, they'll still be just as likely of becoming proficient at it. Like, all they need to do is come to class and watch me do it, and it's cool. Like, it's a spectator sport.
That
like
part.
like I want to see that. I don't think that research exists.
It don't. Everybody's an expert, but I don't know what the evidence is. I will ask you quick. I need the evidence. Where's the evidence? Now, again,
what I said, what was the sample size of that so-called research? and let me say one thing too before you wrap this on that, because I love everything he said. I've always been a fan of homework, but I always limited the amount that I gave them because I don't want to come to think. I don't want you to do 25 problems correctly. I'm no more than 10 quality problems. If you can find you, is most likely, and then now if you got some mistakes, those mistakes ingrained. So now it's easier to help correct those mistakes.
Absolutely. I think that we have to have, like you were saying, it has to be a happy medium for the homework that we're giving. Like we can't give it excessively, and then you don't want to get the homework with and there not be any type of feedback. Like that to me is also pointless. Like if I'm doing a million problems and I don't know if they're correct, I don't know where I went wrong, like I don't know anything about it, then that is also, I think that is a hindrance as well. So I 100% agree with what you guys have both shared this evening. I think that we've had a great conversation, but I feel like we've only really scratched the surface of what we really need to talk about. And y'all surprised me because I thought those few little slides I had, I thought we was gonna go through it like that. But y'all was feeling it in your spirit tonight and you got all wrapped up in it. So is there anything that you want to leave the people with so that they can come back and join us the next time that we come together to talk about math and have these virtual math chats?
I would just say, like, this is like therapy. This is a therapy session for anybody that watches, especially if you're a parent that feels uncomfortable and doesn't feel equipped to help your children with their math homework. Like we're here to help. That we just some black people that know math, and we want to help you know math too. So we could be on here talking about this manufactured gender war between black women and black men, and whether we should go 50-50 or this or that or whatever. We could be talking about any other stuff. We feel like talking about some things that are a lot more important, a lot more impactful, So tune in when we come back. It gets better.
Dana, what you got?
I second this too. We understand there's a lot of parents that have a lot of things going on. It's to the idea that we talked about with homework. You have to, there are here, and we just happen to be three who are providing resources. And we can talk the language of the people, but we can also talk the language of the mathematics. And so if you want resources and you need resources, we know what we've studied and what we are the books and other resources beyond our brilliant minds to help you help your child.
Thank y'all so much, man. It has been an honor to spend these last 60 minutes with you guys. Parents, we are a resource. We are here to share our passion with you guys. As both of the gentlemen said, we want you to feel that you can access this, that you are capable of just engaging with the mathematics. It's not as scary as sometimes it seems. I promise you it's not. There is an entry point for everybody, and we are here to make the entry point accessible for you and your family. My co-hosts here, they have plenty of resources that you guys can just consume from YouTube, for everywhere, TikTok, Instagram, everywhere. So I'm going to ask that they share their handles, their links in the comment section so that you guys will have access to it from today and going forward. And please don't think that these resources are just for you to use for the 10 months that your child is in school, because there is a such thing as the summer slide, and I don't want nobody sliding down this summer. So use these resources that are available to you. Like they said, we will be back. So make sure your notifications are on so you don't miss it. Thank you guys so much. Until next time, make sure you're budding and bearing fruit.
Deuces.